In this presentation, I will talk about the service life of the Pfannenberg Filterfans. This presentation will address the questions: how do we measure service life, what does the L10 value mean, and why do competitors have a higher service life? First of all, we will talk about what service life actually means. So the service life is the measure of time which a device is expected to function safely and as intended. In our filter fans, the point of failure is the fan, more specifically the radial bearing of the fan. Service life can be expressed using different metrics. A couple of them are the MTTF value, which is the mean time to failures, or the MTBF value, the mean time between failures. Another one is the L10 value, which you might already be familiar with, which is the time at which 10% of the products fail. Of course, what this also means is that at this time, 90% of the fans still function. At Pfannenberg, we use the L10 value provided by our fan provider EBM Papst. And in our case, failure means that the sound or the rotational speed of the fan deviates from the expected behavior, so it's not necessarily really broken in that sense. The L10 value we provide is the minimum between the grease service life and the mechanical service life, which I will get into in the following slide. One aspect of the bearing service life is the mechanical service life, and this can be calculated using a standard, which is the DIN ISO 281. And it has two aspects. First of all, the nominal service life, which provides a rough estimation based on the bearing type, the load, and the rotational speed. And then it can also serve to provide a more specific calculation of the service life, which is called the extended service life, which also takes into account grease, installation, manufacturing, and material. For the grease service life, there is no standard as such. However, EBM Papst uses a paper published by the Association for Tribology. In case you were wondering, the tribology is the science of interacting surfaces in relative motion. So this association provides a sound basis for the calculation of the grease service life. In this case, it is dependent on the rotational speed, the bearing diameter, the grease, and the temperature, and it is actually the limiting factor in most cases. This is because fan bearings are not actually re-greased, and therefore the grease is usually what is the limiting factor. So, in conclusion, it can be said that service life does not necessarily equal service life. In our case, we use a realistic practical value in the L10 value provided by our fan provider EBM Papst, which is the minimum between the grease service life and the extended mechanical service life. We also notice that we consider failure conspicuous behavior, which is obviously a more strict criterion than saying the fan doesn't work entirely, so it doesn't rotate at all. And competitors may declare a higher service life, even on the same product, by, for example, neglecting the grease service life entirely, or using just the nominal mechanical service life, using different metrics entirely, for example, the mean time between failure or the mean time to failure. Remember, at our L10 value, 90% of our products still work. Also, our competitors may consider unrealistic temperatures, for example, fairly low temperatures, or just different failure criteria entirely.